Hi everyone, my name is Anika and I'm part of the Stat 107 team, and in this video today we are going to be learning how to analyze Simpsons paradox in some scenarios that we have. So let's go ahead and get started. So the first thing we want to do is here we have a lemonade stand in the summer. For the past 2 months, you have sold both these flavors of lemonade and decide that next summer you are only going to sell the most popular flavor, right? So this is the table that we have here. And now we need to see which flavor here had a higher sale rate in June, right? So when we see our table here, we want to see this June row, right? And the sale rate is calculated here, sold divided by the number produced. And as we can see here, the pink lemonade had a higher sale rate because the 0.08 is greater than the 0.04 for regular lemonade, right? So over here, the pink lemonade would be the correct answer when only looking at the month of June. Now when we go ahead and look at July, we see here that pink lemonade also had the highest sale rate in July, right? Because the 0.6 is greater than 0.3 for both June and July. So in our second question here, we know that pink lemonade also had a higher sale rate in July. Now when we look at the overall sale rate, we know that the regular lemonade actually had a higher sale rate overall when we combine both of these months, when we combine all of our numbers produced for the summer, because the 0.21 is greater than the 0.17. Now, you might be thinking that when we looked at these specific months, pink lemonade had a higher sale rate, so it was a better seller. But when we look at the combined totals, right, regular lemonade seems to have a higher sale rate. Well, when we see this type of pattern, right, when we see groups of data that we're dealing with, in this case, sale rates for each of these months, when we look at the months specifically, we may see one trend, which is that pink lemonade had a higher sale rate than regular lemonade when looking at these months separately. But when we look at the combined data, when we combine these months, we see a reversal of the original trend that we saw. In this case, the regular lemonade is a better seller and has a higher sale rate when we actually combine all of our data. And this is exactly what is called Simpsons paradox, right? When we look at different groups of data, when we look at them separately, we see one trend, but when we combine all these different groups, this trend may disappear, or in this case, it even reversed. So that's why Simpsons paradox can be a bit misleading, and it's important to really divide up your data and look at these trends that are going on in separate groups, but also in these combined groups overall. So now this last question says, what could be a possible confounder? So I know this is not a question, but again, the pattern that we saw here was really an example of Simpsons paradox. And this is true for generally all questions that deal with this sort of paradox, right? You're going to see one pattern when looking at groups of data individually, but when we combine groups of data, there's going to be a reversal of these trends, right? So a possible confounder leading to the effect that was discovered, let's go ahead and read the answer choices, right? A says the heat levels of the months, B says the popularity of different flavors, C is the popularity of your lemonade stand, and D is none of the above. So let's go ahead and actually look at this data to see why this paradox has occurred, right? Why are there different trends when we look at each month individually, but a reversal of that trend when we combine the sales for the months? So we can see here that actually for pink lemonade, the number of lemonades produced, right, the denominator here, is very much lower than regular lemonade, right? We can see that regular lemonade is a lot more popular. For pink lemonade, let's look at June, 500 were produced, and then same for regular in June. But when we look at July, only 100 pink lemonades were produced, but for regular, 1,000 were produced. That's why when we look at the ratio, 0.6 may seem a lot. When we look at July, it has indeed a higher sale rate. But when we actually combine these totals, we're looking at totals of 600 for pink lemonade versus 1,500 for regular lemonade. So we can see here that there's actually a difference in sample size, right? Because the totals is much more for regular lemonade, which is why the combined sale rate is actually higher than what we saw in pink lemonade. And this can especially be seen in July, because when we look at totals of 100 versus 1,000, right, that difference really comes into play here, because for regular lemonade, we're just dealing with a lot more numbers produced, which is why in July, pink lemonade has a higher sale rate. But when we look at the combined ones, regular lemonade has a higher sale rate because there was more produced and more sold out of those total produced. So we really need to look at these sample sizes here and see that, the sample size, the number of lemonades actually being produced is a possible confounder, right? And that's actually not shown in any of these answers here. So the answer would actually be none of the above, because the sample size, I'll say here, the sample size is what's causing this effect to be shown, right? It's becoming a confounder in our study here because we're not dealing with equal sample sizes. Regular lemonade, in fact, has over 1,000 lemonades produced in July, and that's the size is actually that variable, that confounder that's causing this reversal of trends to occur. So if you have any questions, please let me know. I hope this makes more sense, and I'll see you next time. Bye.